Today's lesson is how to integrate a trigonometry function. I'm just going to show you how to integrate the sine and cosine function in this video, and hope by the end of the lesson you should be able to integrate any trigonometry functions you come across using table of integration. Okay, the formula is provided to you here, so I'm just going to rewrite it down again, but this time in terms of t. So integration sine at dt, so the answer is minus 1 over a cosine at plus c. Same thing with the cosine, integrate cosine at dt, the answer is 1 over a sine at plus c. Okay, so now we go over a few examples. Example number 1, integrate sine 2x dx. Okay, according to the formula, the sine, the answer should be minus 1 over a, so a value is 2 here, so it's going to be minus 1 over 2, and the sine becomes cosine 2x plus c. Okay, another example, integration cosine 3t dt. Okay, so the value of a here is 3, so we will check the table of integration. The cosine becomes 1 over a is 3, 1 over 3 sine 3t plus c. Okay, we're gonna do a few more examples. Okay, integration 4 cosine 5x dx. Okay, as we did on previous videos, we can take the number outside the integration, so we can put 4 integration cosine 5x dx. Okay, again you're going to leave the 4 there, and cosine 5x is 1 over 5 sine, cosine becomes sine 5x plus c. All we need to do is to simplify it, so 4 times by 1 give us 4 over 5 sine 5x plus c. Okay, so sometimes you will have the constant outside the integration, so for example 3 integration sine 7t dt. Okay, so we leave the 3 there, and the sine becomes minus 1 over a is 7 cosine 7t plus c. All we need to do to simplify it, 3 times minus 1 will give us minus 3 over 7 cosine 7t plus c. Okay, so we have got an example here, application of engineering. The current IL through an inductor L has a relationship with time t as following. So the formula is current L equal 1 over 2 integration cosine 180 t dt. Okay, the question is find the inductor current when the time is 0.5 second. So basically asking us to integrate this function when time is 0.5 seconds. Yes, there is one thing here need to remember. You see, when we have number here 0.5, so basically that means you have got upper and lower limit. So the upper limit is going to be 0.5 and the lower limit starts from 0 second. Yeah, okay, so we're going to start integrating this function. So IL equal 1 over 2. Okay, that's times the cosine 180t is 1 over 180, and the cosine becomes sine 180t plus c. As we went through previous videos, when we have upper and lower limits, so we need to put the two square brackets around here, put the lower limit and upper limit. Okay, so we can take this constant number outside. So 1 times 1 will give us 1, 2 times 180 will give us 360. Okay, sine 180 t plus c, close the bracket. Okay, now to solve definite integration, all we need to do is replace t by upper limit first, then subtract, write down the equation again and replace t by the lower limit. Okay, so it's going to be 1 over 360 sine 180 times, instead of t we rewrite 0.5. Okay, I do plus c. That's the first one done. Now we're gonna put minus. Okay, we repeat it again, but this time instead of 0.5 we're gonna replace t by 0, so it will be sine 180 times 0 plus c, close the bracket. Okay, as you can see, you've got c minus c. Okay, minus c, these two will cancel each other, so we have 1 over 360 sine 180 times 0.5 minus sine 180 times 0, so basically that's a 0. So if you want to use a calculator, feel free to use a calculator. Okay, so 1 over 360, that will be sine 180 times 0.5 is basically sine 90 minus sine 0. Okay, if you don't know what sine 90 is, basically just type it in your scientific calculator. Sine 90 is a 1 minus sine 0 is 0. So basically we end up having 1 over 360 times 1. So the final answer will be 1 over 360. Yeah, 360. Basically, if we change that to standard form, so the current through inductor is 2.7 times 10 to the power minus 3 amps. If you found this video useful, can you please like and subscribe? Thanks.